Well visits, welcome to grade 12 Maths Term 2. Now as you know, we're going to be working with Tech Maths, which is slightly different. In this lesson for Tech Maths, we're going to be working with integration. Now what is integration? Integration is the reverse of derivatives or differentiation. We learnt about derivatives and we learned how to do derivatives. We also learnt the formula for working with derivatives. What integration or integrals does is we work backwards from that process to achieve an answer. So there is some notation, as you can see, that is available for us to understand what each part of our integration means. Having a look at the notation, we can see that the symbol, which is a slanted S that you can see, it looks a bit like a stretched out S, and that shows the integral that must be calculated. So that symbol governs the integral that you need to calculate. That sign or that stretched S means integrate, and it comes from the letter S, which means summation. We also look at the Greek symbol of summation that you have used during number patterns. Do you remember using that symbol when we worked with number patterns? We used that when we were looking for the sum of or the summation of. That usually means sigma. That term or that symbol is called the sigma notation. Now the general form, which is called the indefinite integral, is written as follows, where y is equal to the integral of f of x dx. F of x is your function, and that is equal to f of x plus c. Now c, if you can see the last sentence, means that it is any fixed number and is referred to as the constant of integration. Do you remember when we worked with derivatives that we said that a derivative of a constant is 0? What integration does is it replaces that constant when we work backwards. Remember, we don't know what that constant could have been. It could have been 0, it could have been 100, it could have been negative 50, 25, it could have been any whole number, because we said that in a derivative of a whole number is 0. We need to replace that whole number by giving it a constant of integration. That constant can represent any whole number. As you work with more examples, you will learn how to substitute and use what we know about integration to find that constant. What does dx mean in that formula? Dx refers to the integral that needs to be done in respect to x. So it's your derivative in regards to x. Therefore, dx. If it was dA, it would be a derivative that needs to be done, or the integral that needs to be done in respect to x. So d represents the derivative. X is the integral that needs to be calculated in terms of that x value. We already know that f of x is the function. When we look at f of x as a function in an integration sense, or in the concept of integration, we refer to f of x as the integrand. Again, f of x is known as a function to us when we work with functions or we work with graphs. But when we work with f of x in terms of integration or in the subject of integration, we refer to it as the integrand. Remember that the c in the value represents the constant of integration. Now, why is integration even used or learnt in mathematics? There are various different uses of integration in real life. One of them being calculating area between curves. You will learn how to use integration when using two curves and you're trying to find the area between or under those curves. It also helps when we are calculating distance or acceleration. You will also use integration when you are calculating arc length or pressure or even kinetic energy. When you work with kinetic energy in physics or in technical science, you will learn to use integrals or integration. Those will work as well for probability. When we worked with probability, we only learnt about indefinite or definite probabilities using events. When we introduce more complex examples or more series of events that will occur that we cannot give an accurate image or perspective on, we start using integrals. Integrals are also used in the architectural industry, where they use integrals to describe or calculate various different lengths and area. Remember, we said arc length was also an important industrial use of integration. So let's go ahead and look at an example of how we use integration. That example will introduce the subject of integration and the notation that we just learnt about. Let's go in and do those examples.
So with this, if we look at the example that we are given, and if we say how can we use that given derivative, so we are given that the derivative of y, so the derivative of some function y is x squared, so the derivative of that is dy over dx, which is equal to 2x. So what are we saying? We are saying the derivative of the following function is 2x. Remember that when we worked with derivatives, we say that a derivative is denoted by dy over dx, which means the function of y in terms of the derivative of x. We want to know what is the integral of 2x. 2x dx, meaning that that part represents the function. So what can we look at? Let's look at if we differentiate. So if we were to differentiate y equal to x squared, we can use the fact that integration is the reverse of differentiation. Do you remember we said that integration and differentiation are pairs that work in reverse? We can conclude that 2x must integrate to give x squared. So we're saying that we can use the fact that integration is the inverse of differentiation, and we can say that we can further conclude that 2x must integrate to give us x squared. So what are we saying? We are saying that if we integrate 2x dx, then we must end up with some x squared value. What do we see? We see that this x squared and the 2x, they go together. But what did we learn? We also learned about a constant of integration. So whenever we have the x squared, we must add the plus c. Why do we add that plus c? We notice that when we perform an indefinite integral, so where we don't have a limit at the top and a limit at the bottom, we refer to that as an indefinite integral. So when we have an indefinite integral, you do not have any limits on the integral sign, but there is this plus c. Why do we have that plus c? We have that plus c because of the constant of integration, and we learned that we add that because whenever we differentiate a value or a constant value, we usually say that a constant is 0. So the derivative of a constant is 0. So when performing an indefinite integral, we can check the answer by working backwards and working forwards. So if you return to the function you are integrating to begin with, then you can see that your answer is correct. We can say then that y is equal to x squared plus c. We can say that the derivative of this will be dy over dx, and the derivative of this will simply be 2x, which is the function we were integrating. So the most important thing for us to note in terms of integration and differentiation is that you can work both forwards and backwards. Now this is a simple example, but every example requires you to do additional work. Now in the next video, we'll be speaking about rules and what rules govern integration. you will also learn how to mix up various parts of integration. So, for this video, the most important thing that we need to know about the structure of derivatives and integration is we can say that if we wanted to look at the basics, we can say integration and differentiation go hand in hand. So when we look at differentiation and we look at integration, we can either look at the integration and work to find the derivative, or we can know the derivative and work to find the integration. There are two benefits of working this way. The first one is you get to check your answer. It's very important that you learn to check your answer using the reverse operation. And the second importance of learning both integration and differentiation is that they work together. So you learn them in pairs. So you can learn both sections at the same time. Why do we say that that makes it easy? That's because if I learned integration and if I struggle with differentiation, if I perfect integration, I'll be able to work backwards to find the derivatives. If I learn derivatives and differentiation and perfect that, I can work with that to find integration. How does that work? Well, if I have the integration or the integral and I said I found it to be x squared plus c, and I know the derivative is some value 2x, then you can work backwards and forwards. That will help you when you do the worksheets or you do practice examples. Also remember, you might be asked to find what each component of an integral is. Now with this, if you go back to the example that we've worked with, it is very important that you understand that the integral we were working with is an indefinite integral. So we were working with indefinite integrals. A definite integral will look something like this with an a value and a b value. So look out for more videos that will help you understand indefinite and definite integrals.
So wizards, we've learned how to use integration. We've learned how to do an example using integration. Now the examples may seem complex, but if you break it down the way that we have, it makes working with integration a lot easier. Remember that you have definite and indefinite integrals that you need to work with. In order to improve your knowledge on integration, iWiz is offering you access to worksheets. Those worksheets are located on our website. Go ahead and look at those worksheets, try to attempt them and do as many as you possibly can.